today I created the solution for anti-palindrome, and it actually got a decent amount of views depending on my channel. And I got this comment, and so I decided to create a video on this question also. So let's read the question. So the question states that you are given a positive integers x that is at most 10 to the power 8, and you have to find three distinct non-negative integers a, b, and c that do not exceed 10 to the power 9 and satisfy the following equation. Pretty straightforward. And one thing to note here is that these are non-negative integers, so you can use 0 technically. And what this gives a hint is that the a, b, and c can actually be greater than x, right? So this is the question. So this is the equation, and you just have to find three integers that satisfy this equation. I think this is pretty much the question, and it can be shown that the answer always exists, that a, b, and c are always findable. So we can go on test cases, or we can just go straight to the solution. Okay, let's just go straight to the solution. So this is the equation, right? So let's reduce this to be p, q, and r. So basically this whole thing is p, and this whole thing is q, and this whole thing is r. So there are three different numbers that when and with each other give us x, right? So x is always less than equal to p, q, and r, because if you look at the AND operation, let's say we are given this and we are given this, so we can see that there are no new bits formed in an AND operation, only the bits are turned off because of a certain number. So actually the AND of two numbers is always less than or equal to both of the numbers. So this is something that you should know, right? Now this was kind of an assumption I tried to take, that what if I can just make q and r useless, right? I tried to do that. So what I did was, let's say p is equals to x, right? So if we take p equals to x, and since we know that p, q, and r can be x, right? And this can be x. If all three are x, then also we can make the AND of all three numbers to be equal to x. But let's just say p is equals to x. Then what can q and r be, right? So q and r can be x or any other number that have bits similar to x set in them. So whatever the bits set in x are, they should be set. Only then can the AND of all three numbers will be equal to x. So if p is x, then q and r should be x or any number that have more bits set in them, like from x, right? So x, the bits that are set in x, that should be set, and plus there can be more bits that are set. So an efficient solution was to set all bits in them. So basically make q and r to be numbers that have all bits set in them, right? So to do that, so how can we make q and r to be total 111, right? Because we can't set the value of q and r, we can just set the value of b and c and a, right? So if we look at this, we can control this by c. If c is a number with all bits set, then the OR of b with c would only be c, right? So b or c would only end up being c, and c will be equal to 111, all ones, right? So this will be c, and this will also be c, and we and this will actually turn out to be x. So if we just AND x with c and then again AND it with c, so these two have all bits set in them, so the answer will always be x. So now that we have found out that if we set all bits in c, then we get these two terms to be all bits set, and then we can print out the answer. Now the only thing that is left is we need to find two numbers a and b, which when odd give us a value of x, which is pretty simple. So what I did first, what I did a mistake was, like let's say x is 11001, right? And we need to find two integers a and b that when odd give us x, right? So what we can do is we can take one bit and then set all of the others to 0, and then take all of the other bits that we did not take earlier and then assign it to b, right? So this can be our a and this can be our b. Pretty simple, right? This is like when we OR this, we will get x. So we can do this randomly. But what if there is only one bit that is set in it, right? So if there is only one bit set, then we can just use 0, right? So I did not know that we could use 0, and after this test case, I knew I could use 0. So two numbers that when odd, which give us x, can be 0 and x itself, right? X can itself be used, and the other number can be all ones, basically all set bits, all bits set, right? This also explains why we can't make q and r to be x, and we have to uh, use a different number that have all bits set c to b, because these three need to be distinct, so we can't make c to also be equal to x. So how do I do that in code, right? Okay, so I just declare a count variable. What I'm doing right now is basically finding a number that has all set bit set and that is greater than this x, right? So let's say the highest set bit in x. I'm just finding the highest set bit and then making a number with all ones set in it, uh, less than x, right? Let me explain. So this let's say this is the number that is x, so 1 2 3 4, and we can see that the fourth bit is set. And now what we have to do is we have to find a number, let's say 1111, right? We have to find this number. This will be our c, right? But how do I find this? To do this, I just find the location of the highest bit in b, basically x, and what I do is left shift 1 by that amount, so I'll get this number, right? And I just left shift it one more time, so I get this number, and when I decrease 1 from it, then what I'll get is a number that has all ones and it is of the length x when represented in binary form. So this is what I have done, right? So we have left shifted one count plus 1 times, right? Right, we have to do it one more time, and then we have decreased 1, so we have all bits set and the length of this is actually equal to x. And yeah, then we just display 0 x and that number that we just found out. Yeah, so this was my solution. Comment down below if you have any doubts. And yeah, so this was my approach. This can be done by various other approaches, I think. And yeah, um, like if you like the video and subscribe if you loved it. And thank you for watching.